Okay, so in today's section, we're going to look at proportional reasoning. So let's just remind ourselves of a definition. A ratio is denoted as either A over B, or A to B, or, sorry, I shouldn't use that symbol, or A with colon B. Like all of those all imply the same concept. Okay, so what we then define as a proportion is when we have two given ratios are equal. So anytime we set two fractions equal to each other, we're saying we've got some sort of proportional relationship. Okay, and then formulaically, I'm going to show this A over B equals C over D if and only if, and that's that rule that we all learned earlier in our lives about cross multiply. So that's true. Two fractions are considered equivalent if A times D equals B times C. So if I cross multiply and they give me the same number, then I can state that we have a proportional relationship. Okay, so let's do an example of this. If there are 3 cars for every 8 students, how many cars for 1,200 students? Okay, so we're saying then we've got the number of cars and the number of students. So I kind of look at this a little more in depth here. If I have 3 cars for 8, how about if I have 12,000? How many cars would I expect that to be? Okay, so we're going to set up a nice ratio. So 3 over 8 equals x over 12,000. And I'm going to cross multiply. So 3 times 12,000 equals 8x. Okay, so that gives me 36,000 equals 8x. So then how do I solve for x? We divide by 8. So then x would be 4,500. So assuming that relationship holds, then I would expect there to be 4,500 cars. Alright, if the variables x and y are related by the equality y equals kx, then y is proportional to x. And k is considered to be the constant of proportionality between x and y. Okay. Okay, so I want to attach sort of an example with this. Let's look at a sort of a rental car company. And I'm going to give you the following information, and we're going to come up with a proportional relationship here. So we're going to look at days and cost. 1, 2, 3, 4. Okay, so I'm going to tell you that for 1 day it costs $20. For 2 days it costs 40. For 3 days it costs 60, and 4 days it costs 80. Okay, and what I want to know is how can I use cost to predict the number of days? In other words, is there some sort of formula that I can you tell me the number of days and I'll tell you how much it costs, right? Okay, so what do we notice? We notice that as I increase 1 day at a time, my cost goes up by $20, right? So if you tell me how many days, I'm going to multiply that by 20 and that'll give me the cost. Okay, so what do we have here? I have that cost is proportional to days, and in this example the constant of proportionality, so our k happens to be 20. Now I can just as easily rewrite this in terms of days equals something for cost, and that's just as easily going the other direction. So if I do costs divided by 20, so 1/20th, then I get k over 120. Okay, but either way, once I've got a proportional relationship established, that number that I multiply by to get the other number, we call that the constant of proportionality. Okay, so aside from setting up a proportion and solving, there's some other techniques that we can use to actually solve proportional problems. One of them is referred to as a scaling strategy. Okay, so let me give a scenario. So let's say I've got two options. I could buy 12 tickets for $15, or option 2, I could buy 20 tickets for $23. And I want to, and I'm not saying I'm going to bring 12 or 12. I mean, obviously, if I'm bringing 12 people, get the $12 option. Bring 20 people, bring the $20 option. But I would like to know, generally speaking, which approach is the better value for my money. One way to think of that. And so what I could do is I could look for the least common multiple. So find the LCM of 12 and 20 using techniques that we've seen earlier. So I would start with 12 and 20 and go, well, let's see, 12, 24, 36, 48, 60, 20, 40, 60. Okay, so it looks like if I take the 12, so they both have a commonality of 60. So using plan A, the first plan, I could buy 60 tickets for, and I just need to multiply that by 1, 2, 3, 4. So 4 times the 15. Let's see, hold on, let me make sure I'm doing this right. 5 times 12 is 60. So 5 times the 15 is $75. And with the plan 2, let's see, so I want 23 times 3, which is $69. Okay, so just back up what I've done is I've scaled up both proportions till they have the same amount on one side, and now I can compare the dollar amount on the other, and that sort of helps me make a better plan. And it looks like plan 2 is the cheaper option of the two. Meaning I can, if I invite 60 friends, I'm going to save a couple bucks going that route. So that's one strategy, is to scale up. Another strategy is to look at a unit rate. So let me go back to those two plans for a second. Let's see, we had 12 for $15 and 20 for $23. Okay, so I could look at how much for one ticket. So if I take the 15 divided by 12 or the 23 divided by 20, and convert that. Let's say we're just going to do decimal on this. So this would be $1.25, and this would be $1.15. And now per unit rate, you can see that Plan 2 is still cheaper, that you're spending less money per ticket with that first plan. And again, real life kicks in. It's like, well, you know, it kind of also depends on how many people you want to invite. So if you're only going to invite 13 people, I mean, obviously Plan 2 is Plan 1 would be the better choice. But again, we're analyzing this from a cheapest on the unit rate side. Okay, scale drawings are a nice fun way to get students to see the value of proportional reasoning in their own lives. You can pose the question, if you wanted to rearrange your room without actually have to physically move in the furniture, is there a way you could do it? And you could talk about, well, what if you measure the dimensions of your room and measure the dimensions of your furniture and created smaller miniature replicas of them, not 3D, but like a 2D flat dimensional thing. And so we refer to as a scale drawing, or the word scale is simply the ratio of the size of the drawing to the actual size of the object. Okay, so with the room assignment, you could have students measure out, take a ruler and physically measure out the size of the wall, the size of the door, the bookshelf, the bed, the various features that are in the room, and have them create a miniature scale of it. So they might, little floor plan here, say a typical home, and we could say that this is the room that we're interested in. And so for a scale drawing to work, you need to have some sort of relationship that you can measure. So let's say our scale is 1 to 300, meaning 1 inch is equal to 300 inches in actual living room space. So if I measure this out, let's say this measures 3 inches by 8 inches, how big is the actual room that we're looking at? I would take each of the inches and multiply that by 300. So 3 times 300 is 900 inches, and 8 times 300 is 2,400 inches. And then we could bring up well, what if we want to convert that into feet, and hopefully students will recognize that there's 12 inches in a foot. So if I take both those numbers and divide that by feet, let's see, so this would be 75 feet by 200 feet. So the original dimensions of the room, well, that's actually a pretty big room now that I've seen it. But anyways, so that's how scale drawings work, is they use the scale concept, or that constant of proportionality, to shrink down their room or shrink down a space into a smaller version of it.